So on number 5, this is called a piecewise function because it's in different pieces, and the only difference between it and the other limit problems is you have to pick what your function is going to be. You have to pick which piece to use for your limit. It's very easy to do that though. This says 1 from the left. That means numbers less than 1. Well, which one of these is less than 1? Obviously the one that says less than 1. So I'm going to use the 2x plus 5 for my function. So I use 2x plus 5. Now it's just like 1, 2, and 3 from the previous page. All we have to do is plug in. If we get an answer, we're done. If we don't, then we could either factor or do our 0.9s and 0.1s. In this case, we get an answer, the limit's 7. Now, on the is it continuous or not, to be continuous, there are 3 things that must happen. And the big mistake is only doing 2 of them. So you have to have 3 different pieces and they all must equal the same number. So the first piece would be the left-hand limit, which we just found, and it was 7. The next piece would be the right-hand limit, and the last piece would be f of the number. Be very careful. If you do not find f of the number, you're not really going to know. The limits can equal, but that doesn't make it continuous. All 3 must be found and equal each other. So right-hand limit, we would use what's on the right, so something bigger than 1. So x squared plus 4, plug in, and we get 5. F of 1, this is the equal sign. So in our problem, the equal is here, so we're going to plug into 2x plus 5. So we're going to use 2x plus 5, and I would plug in, and so I get 7. Notice, not equal, so it is discontinuous. All right, on number 6, it says, where is f of x discontinuous? Well, fractions are discontinuous when the bottom is 0. So discontinuous for a rational function, and that's what this is. Rational means there's x's in the bottom. Discontinuous for a rational function where the bottom equals 0. So to find where it's discontinuous, all we have to do is set the bottom equal to 0 and solve. This is a factoring problem. So I do x minus 2 equals 0 and x minus 1 equals 0. So x equals 2 and x equals 1. The function's discontinuous at 2 and at 1.